Technology advances by rapidly these days, and it had better keep doing that if we're going to send people to live on Mars within the next few decades. In fact, NASA plans to send their first manned mission to Mars as early as the 2030. But there are a few key pieces of technology humanity will have to improve on before we can hope to reach the red planet safely. In this video, we discuss about those things. Mars suits. The environment of Mars presents some interesting challenges, with plenty of dangers that might not kill the colonizers right away, but could cause severe health problems down the road. Exploring Mars would require special suits even more advanced than current spacesuits. For starters, Mars is frequently bathed in deadly space radiation. On Earth, we're protected from these cosmic rays by the atmosphere and a magnetic field known as the magnetosphere. Orbiting spacecraft like the International Space Station are inside the magnetosphere, so only a few astronauts have risked full exposure to space radiation on brief missions beyond low Earth orbit. A trip to Mars would take much longer, making radiation shielding vital. That's particularly tricky for Mars suits, which have to be light enough to wear while also providing adequate protection. One candidate might be hydrogenated boron nitride nanotubes. Originally developed to shield spacecraft, researchers have actually made BNNTs into yarn, which could be mixed with the fabric of spacesuits to provide protection from radiation. Also, according to YouTube statistics, only a small amount of people actually subscribed. If you like this video, consider subscribing. It's free. You can always change your mind later. Builder bots. We can't just dump people on Mars with no infrastructure in place and expect them to build everything they need themselves. All realistic colonization plans envision first sending unmanned ships loaded with supplies, along with robots to do the prep work before humans can arrive. For example, robots could construct livable habitats and begin extracting water from the soil long before the first human sets foot on the red Martian soil. The problem is that we haven't yet built these builder bots, and the robots that we can currently build are fairly limited in what they can achieve on Mars. At present, NASA is working in conjunction with 2 universities on a humanoid robot dubbed the R5. They argue that we should simply do as much of the work as possible on Earth. For example, pre-built inflatable shelters could be set up, saving us the trouble of creating a robot to construct the shelter from raw materials. Homes. Clearly, a key step to colonizing Mars will be designing specialized habitats for the colonists. These habitats will need to be pressurized to near-Earth levels. They will also need to protect against dust storms, radiation, and frigid weather conditions. And they'll need to be homey, since future Martian colonists are probably going to be spending a lot of time indoors. And life on Mars would pose even more unexpected challenges. For example, it seems intuitive that Martian colonists would grow edible plants in their habitats. The problem is that plants produce oxygen, which would build up in a sealed environment until the air became toxic to humans or everything burst into flames. And it's difficult to vent excess oxygen without also losing precious nitrogen, a vital atmosphere component. So before any space farms are possible, engineers will have to develop a robust system for removing excess oxygen under Martian conditions. Ultimately, it's too early to say what a house on Mars might look like. Water extractors. Despite the recent discovery of some liquid water on Mars, future colonizers are going to be dependent on frozen water trapped in the Martian soil. Extracting that water might involve physically digging it up, or it might mean using microwaves to vaporize the water and bring it to the surface as a gas. Unfortunately, while machines to do both have been tested on Earth, no large-scale water extractors have yet been tested on Mars itself, and it's definitely important to make sure that machinery works before we consider establishing a permanent base on Mars. That's not just so that the colonizers don't die of dehydration. Some experts have suggested using the water to supply oxygen by separating the hydrogen and oxygen atoms that make up water molecules. If you like this video, consider subscribing. It's free. You can always change your mind later.